Okay, welcome back. Let's continue where we left off. I had some issues, so I'll just continue with part one. This is a continuation. So, welcome back. I'm gonna continue with part one. I had some issues, so let's continue where we were. So, as I was saying, there's two types of ways to group data or to group data to represent a specific entity or an object. You can use the class approach, of which the class is like an advanced version of a record structure. It's one and the same thing. The only difference is that with the record structure, everything is public by default. And we talked about what's the issue with that. Then with the classes, everything by default is private. And with the nice thing, with classes, everything is default by public, and um, you should also normalize um, things that grouping things in terms of their level of access. So group in terms of the level of access. So is this thing gonna be private to the user to that person, or it's gonna be public? Is it going to be private? Is going to be protected, or it's going to be a friend? So in order for us to specify the level of access, we use what we call access modifiers. So the access modifier basically states the level of access that you have in order to modify the data. We can put it in simple terms like that. So we can have the private access modifier, we can have the public access modifier, we can have the protected access modifier, we can have the friend access modifier. Private modifier, it means that it's only private. You and you alone has access to this information. For example, your bank PIN. Then public, everyone has access to this. For example, a bus or transport or the mall, that's public. It's free for all. Then protected, it's like a recipe passed down from one generation to another. It's like that. It's like a recipe. It's like basically a recipe is public to anyone who's part of that family, right? Who's part of that family tree. But then at the same time, it's private to people who are not part of that family tree. So that's where protected becomes very useful. So we usually use protected. We not usually we only use protected when there is inheritance, when we're defining relationships between objects. So one object is related to another object. So it's part of that family tree. So we can use the protected keyword. So remember, it's public to anyone who's part of the family tree and private to people who are not part of the family tree. Then we have friend. Friend is basically an access modifier that says that um, I can they can only be accessed between two things, for example, two things that are I would say not they're not related, that are friends of each other, friends of each other. That's the simplest way to put it. It's even in the name itself. It's friend. So if my friend is good at something, I can borrow his skills. I can just talk to him and be like, um, hey, can you help me out with this? You're good with you're good with physics. Can you help me with this assessment? You see, that's your friend. So that's where friend comes into place. If you just use friend if you are just borrowing something from from your friend or someone whom you deem close to you, or you can state that this thing that I'm creating should only be accessed by friends. So in a way, it's like another version of protected, but this one works with friends. If you guys are friends, are really close friends. So we're gonna use these access modifiers, these labels to specify the level of access that the user is going to have, which makes sense because, for example, there's things that are public to a person and things that are private to a person. So, for example, we can see your body. That's public. Everyone can see your body. But then secrets, each person has their own secrets. So that's private information. Then there's protected information. There's a family secret, something that can only be known between family members, people of the same family tree. Then there's also friend, things that um, things that can be known only between friends. So just remember it in that way. So let us begin, and you can specify both properties and behavior. So you can specify both variables and functions using this label. You can say that this is a private function, this is a public function, this is a protected function. You can do it in whatever way you want to do it. And remember what he said, a record structure is only for data, if you just want to represent data. So let's start. So the University of Johannesburg, let me zoom in. So the University of Johannesburg needs you to create a data structure called UJ image. So for now, we're not going to conclude what type of data structure it's going to be, because it could be a vector, it could be an array, it could be any data structure, it could be a linked list, it could be anything. We're not going to create the data structure yet. We're going to read more information to understand what's going on before we conclude what type of data structure are we going to create. It should contain a two-dimensional array of structures. So basically it should contain this variable, which is basically an array of structures. The keyword here is structures. Structures basically mean an array of a record structure. They're just telling you create a record structure. And then this record structure must we must use the that new type that you've defined, because remember what we're doing with record structures and classes. You are creating your own data type. So what they are saying is that you must create your own data type using using the structure, because basically it's a data structure that only represents data or information, uh, just data, no calculations. So you need to use that. So you create a record structure because we only want to create to represent data. So we're going to use a record structure, and we were told explicitly to use a data structure, to use a record structure. And then after creating that new type or defining that type, we need to use that name, that new name, and create a two-dimensional array. Then we need to put it inside of this structure called UJ image that we don't know what it's all about yet. So this array of structure should be representing pixels. So it's sort of like a hint of how you should name it, because you should give the record structure a meaningful name that explains what it's supposed to do. Other people who are going to read your code shouldn't have to prophesy what that record structure does. So a single pixel for a color image is defined as follows. So as you can see, they said it should represent what? Pixels. Now they're telling you information about each pixel. So basically they're telling you the information that should go inside of the record structure. So we're gonna do that, but for now, what I'm going to do is okay, before we continue, remember we downloaded the files, the main.cpp. Okay, I'm just gonna copy this file because I'm gonna need to use it. And then I'm gonna copy it inside this folder. inside of my project folder, so that when I try to read from that file, when we get to file handling, it's going to be easy to do. So let's continue. So a single pixel is going to represent, it's going to have this information. Before we continue, we need to find out what UJ image is, because this record structure that we need to create, it needs to be a part of that class. So wherever we are creating or defining UJ image, we need to create that record structure in the same place. So if we read down continuous, we skip all the other unnecessary information. We don't need that yet. For example, when an image is drawn, are we drawing yet? No, we don't know anything about drawing, so we're just going to leave that. Then we get to this part. So this part T1, because T0 talks about the design, just creating your UML diagram. We don't want to do that because we are currently inside code blocks. We are not inside DIA. So let's continue. You must create a class. That's the nice thing. They tell you what you must do, which makes things easier for you. So it should actually be a class. So remember the way we create a class. We divide it into, we use the concept of abstraction, basically, which means that you're keeping the logical properties separate from the implementation details. So with that being said, it basically means that don't put one thing in one file. That's going to be a problem. So for example, don't try to come here and create a class called UJ image like this. And then in the next line, you create other classes and then you inherit. Then no, don't do that. It gets very confusing because now you're going to have roughly like 1,000 lines of code. And for you to make errors, it's going to be the probability for you making errors is going to be very high. So let's just avoid that and use the divide and conquer approach. So you can go to file at the top there, as you can see, file. You click file and then you say new, and then you can either do the shortcut of creating, just say create a class, then you just pass the name of the class and blah, blah, blah. You can do that. And then it's going to generate both the header file. If you check here, it's going to generate both the header file and the CPP file, and it also does the includes. You can do that, but for the sake of demonstration, I'm going to do it file by file. So I'm going to just say create a new file, and then I'm going to create a header file first. Then I put the extension there, .h. Then there we go. Select all, because if you don't select this, you won't be able to run your code. So you need to select this option. And then there we go. We have our header file. Then we're going to have another file for our implementation. This one stores the implementation details. So the concept behind header file and CPP file, what it means is basically the header file is like a promise. It's like you keep a promise. You tell, for example, your partner promised they're going to buy you Ferrero Rocher. That's them making the promise here in the header file. And then in the CPP file or in the implementation file, that's them for keeping the promise. Remember, they promised to buy you Ferrero Rocher, so they need to fulfill that promise. So that's the only difference between these two files. One is about planning, making promises, doing all of that, and then the other file is fulfilling those promises. So that's all you have to know for now. And then we need to create a class called UJ image, right? And then they say this class must make use of principles of good design known to you. It must additionally make use of a two-dimensional array of structures. The UJ class must use its default constructor to read the files to obtain the rows, columns, stochasticity, and seed values for all pixels. So can be too much to read. Just do one thing at a time. So let's start with this part. Create the class called UJ image. Let's go and create the class. And remember, we're going to define the class inside the header file. So class UJ image. There we go. Done. I've created the class. That's all that statement says. The class must make use of good design principles known to you, which means you must create your constructors, destructors, all of those things, accessors, all of those things. They're just telling you indirectly. They don't have to explicitly tell you one by one. So you might just know how to design a good data structure, which is a class in our example using a class. So yeah, we're gonna have to do all of that. Before we do all of that, let's go back to the top here. Okay, and another thing that's gonna give us a hint on what sort of methods we're gonna have. We look at the main.cpp that we provided with and know what things that are we going to have to make use of. For example, if you check here, I have a UJ pixel. And if you remember, anything that I was talking about a pixel is this part that talks about creating an array of structures. And then it tells you that a single pixel should be defined as this follows. So the record structure of the pixel should be defined as follows. If I look at my main, this UJ pixel, it means that this is how I'm going to name my pixel or my record structure. So I've noticed something, and I'm going to have a draw function because this is an instance of the UJ image. And then I'm going to need to use the assignment operator, the pre-increment operator, and I need to have this file testing functionality for saving pixels to a binary file. So I need to have a file that saves to a binary. I need to have a function that saves to a binary file. So yeah, and then all my individual members must be given these names inside of my what? Pixel. So I've inferred a lot of information from the main that was provided. And you can see we are accessing, so I need to get accessors, get rows and get calls. I need to also get the pixel. I need to also set the pixel. So I need to have both accessor and mutator for the two-dimensional array of structures. So let's create the array of structures. So a single pixel. And remember, based on our main.cpp that we're given, I know how to name it. So I'm going to call it UJ pixel. And then each pixel is gonna be named like this: int green, int red, int green, int blue, RGB. So, and if you check, this is the information. We need to have a red, a green, a blue, an integer in that range. So an integer in the range is 0 to 255. And then another integer from that range in the same range, and then another integer in the same range. We are making what we call a P3 image. So a P3 image is basically a color image that uses where each pixel is represented by 3 values: red, green, and blue. So, and the range of each color, it ranges between 0 and 255. 0 meaning minimum intensity, and then 255 meaning maximum intensity. So let's create our record structure, our member variables for the record structure. All of them are integers. So I'm going to have int red, then I'm going to have int green, then I'm going to have int, okay, let me remove this and make it a bit brighter. And then I'm going to have int blue, red, green, and blue. And remember that the range of this should be between 0 and 255. 0 and 255 for all of them. So I'm just going to put this comment here so that I don't forget. when it comes to enforcing the range. So I'm going to do that. It's going to be 3 integers within that range. And then the last thing that I'm going to have, because remember, they said a single pixel. So also this seeds variable is going to be part of that record structure. This is a fixed length array of length 5. So it's a fixed length, which means that it's going to be int seeds like this, right? And then I'm going to put a 5 there. So the problem with having to hard code this, like the 5, putting the 5 there, imagine every time when you have to use this array, this fixed array. Obviously, you know that it's 5, but the problem is that you're gonna have to you keep using that same 5 value in all the files that you're gonna create. So if you do a for loop going through all the individual values in the array, you're gonna use the 5. So what I suggest is that create a constant, because let's say in the future they say, okay, the 5 value is no longer 5, it's now 20. That means I must go to every single header file and CPP file and change that value to 20, which becomes a problem. So what I suggest you do is you create a constant. So const end, and then you call it length, and then you say is equals to 5. Then now you pass that label or that constant there like this, so that in the near future, when you have to change the length, wherever you use this array and you use the length, you just change here and just change this to 20. Then that's it. So you need to, it might not seem quite useful right now, but trust me, in the near future, it's going to be very useful. Once you write a lot of code, even if it's in a different language, the same concepts apply. So we've created our two-dimensional array. So what we are done with our two-dimensional, well, not two-dimensional array, our record structure. We've created our record structure. So now we need to add this functionality to the class, right? So they say the class must make use of principles of good design known to you. So this is your constructors, destructors, and member variables, and accessors and getters, without the operator overloading or the operators, because that's optional. So we're gonna just leave that for now. So I'm gonna create a public label and everything after this colon is gonna make that information public. And then I'm gonna have a private label that states that everything after this colon is gonna be private, which is very important. So, and if you remember it when you talked about the importance of keeping things private and public, yeah, we don't want this thing to happen whereby someone goes to the internet and says, can I have Elon Musk's banking details? Yeah, some information should be kept private and some information should be public. So I need to have these two access modifiers that state the level of access that lists the things based on their level of access that the user has. For example, your intestines are not public, right? And they are not public for a reason. So yeah, just something to think about. So let's create our two-dimensional array. So everything that's data, basically variables, needs to be private. Then you create what we call an accessor, which is a function that is used to access a specific variable. Or you can use a mutator to change the specific variable. And you can change that based on the requirements. If the user needs to update that variable, they can update it via a function or via a method. A function inside of a class, we call that a method. So they can change that via a method instead of having to have direct access. So they only work with the copy. What the functions do is they make you work with the copy. So for example, if you're getting the rows, you're not getting direct access to the rows. The get rows function just takes the rows value and then makes a copy, and then the copy can be accessed via the getRows accessor function, or that name called getRows. You don't work with ._rows directly. You work with getRows, which means you're working with the copy, which is very good. For example, you don't want clients to be able to change their bank balance. You see, so it's very important. So we need to have a two-dimensional array of pixels. So remember that when you create a structure, in a way you're saying define a new type called UJPixel, and each pixel is going to have this information. That's what that means. So now each pixel has that information. I need to create a two-dimensional array for that pixel. So I put 2 pointers because I need to dynamically allocate memory. So what does that mean? It means that I don't know the size. I'm going to get the size from external sources, which is in this case, which is the user. The user is going to give me the, okay, in our case, it's not the user, it's a file. So I need to use pointers, and then when I want to when I want to allocate memory, I will replace each pointer with square brackets and then put the size there, like the way we would normally create a fixed array, an array of fixed length. So that's why we need to do this. Why am I putting 2 pointer? Because the way pointers are in C++, each pointer can represent a dimension. So they want 2 dimension. I must put 2 pointers. If 1 pointer represent 1 dimension, 2 pointers obviously represent 2 dimensions. So I'm going to call it underscore pixels. And then I'm going to store the size of each dimension, which is going to be rows and columns. It's going to have rows and columns. So it's going to be of type int, and then underscore rows. And then I'm going to say comma underscore calls. You can avoid repeating yourself. If variables are of the same type, you can just separate them with a comma. So this one line means the same thing as int underscore rows, int underscore calls, but it's just a shortcut of that. It's a shorthand of doing that. So we have our two-dimensional array of pixels. Then I remember reading about the default constructor. If you check here, it must make use of its default constructor. So we know for a fact we're gonna need a default constructor. Other constructors are optional in this scenario because you're not gonna use it. I mean, they didn't explicitly tell you to have those different variations of constructors. So it's not necessary, but we're just gonna put it there. So I'm gonna have UJ image, and then I'm gonna have UJ image, and then I'm gonna have UJ image, and then I'm gonna have the destructor. There we go. So what's the point of having all these constructors? So remember what constructors are. Constructors are basically tools, or yeah, I'll just say tools that help us build the object. And these tools, or okay, let me not say tools. If I say tools, it's going to be, let me say builders. These are the builders that help us build the object. And these builders can either take in information from the user, basically the requirements. How does the user want us to build the object? We can take that information. Some can not take anything because some users might not care about how you build it. They just want the object. So that's why you're going to have a variation or a different number of constructors to make sure we accommodate all different types of users. So the first one is going to be parameterless. The user doesn't care. They won't provide us any information. Then the second one, they only provide us with the size, which is the number of rows and columns. So you might see this notation and be like, okay, why am I doing this? It's good because I just want to provide with the prototype. This is what we call a function prototype, but in our case, this is a constructor, so we're gonna call it a constructor prototype. So prototype meaning that you define the types of arguments or the structure of that specific thing. So I'm defining the structure of the constructor. It's going to be a constructor that takes in 2 integers because I'm not going to code inside of the header file. I don't need to say int rows, int. I don't have to do that. I can just tell it this is how it's going to look. It's going to take 2 integers. That's all you need to know for now. Because either way, that's how it translates it. This variable that you create when you say rows like this, it's a way to access that first parameter. And when you say columns here, it's a way to access the second parameter. In this case, we don't want to access them. We just want to write the plan. We're just making the promise. And then the last one is going to take in everything. So the rows, the columns, the size of the pixel, and the default pixel. How do they want the pixel to be by default? So UJ pixel, that's it. There's the UJ pixel. And we can take it by, I think we can just take it by reference. That we just see as time goes on. Yeah, we just see as time goes on. But I think this is the best way to go about doing it. Let's take it by reference. If it complains, we just take it by value. Because remember that the structure is gonna be of some size or whatever, and it's gonna have values. And then remember, this is gonna be 5 values because it's of length 5 plus those 3, that's 8 values. Yeah, I know it's not that big, but yeah, we should just normalize getting the address instead of the value. Then we're gonna have a copy construct. What the copy constructor's purpose is to just make a copy of another object. So it's like, for example, this is the lazy type of builder. This builder is lazy. He just copies what someone else made. It's like, for example, you have a practical and then you don't think for yourself, you just copy what your friend did. That's another level of laziness that you don't want. So what this builder does, he just makes a copy, right? This builder doesn't want to make changes. They just want to copy exactly as it is. Since they want to copy exactly as it is, I'm just going to take in another UJ image because at the end of the day, this type of builders, they're building what? A UJ image. So this builder is just going to copy. So this builder is going to take in a UJ image, but you don't want to take the UJ image by value because remember, it's going to make the systems very slow. So you're just going to take it by address or by reference. And we just want to make a copy. Remember what a copy means. So for example, you go to a printer and you print, you make a copy. Do you change the original? During the process of copying, do you change the original? Do you suddenly remove paragraph number 1 and then change it and then put the last paragraph? No, you don't. You just leave it as it is. So you just make it a const to make sure that it doesn't change. It's a constant UJ image, you're taking it by reference. And then these are all the different type of builders that we have, or the different types of constructors that we have. Okay. I just wanted to double check if it's still recording. So these are the different types of builders that we have. So this one, the copy constructor, this one is very lazy. He just copies what somebody else did. This one is very productive. He takes all of the necessary details that are required to make the object. And then this one just takes in some of the information. And it's actually, I wouldn't say it's not their fault, the builders, it's just based on the requirements. Some users just want to give you how big they want the object to be. For example, I want my house to be this big. I want it to be so many acres. I want it to have, yeah, I just want it, they just tell you how big they want it to be. Some users will be like, okay, I want it to be this big and I also want it to be a double story. house, something like that. But in our case, we are drawing a UJ image, so we are specifying the size of an image. And then this is what we have so far. This is what we've been taught about good design, destructors and constructors. And if we check our main file, for now, we're just creating methods, constructors and methods. That's what we're creating. If we check our file, we need to get the rows. We should be able to get the rows and get the columns, and also get a pixel, which takes an RC. What is RC? It's two integers which specify the row and the column. So let's start with the accessors. So with the accessors, here I'm going to have constructors. These are the builders. Then at the end of the day, we're going to need to be able to destroy. So this is the destructor or the destroyer. This is like the demolition team. Demolition team. Demolition. Got out how to spell that, but yeah, demolition team. That basically, those people who come with those tools or whatever to destroy the houses that are no longer being used or whatever. This is what this destructor is. It destroys. If something's no longer being used, it just goes there and destroys it. And then these ones are meant to build based on what the client wants. So I'm going to create an accessor for the rows and columns, call it get rows. And then I'm only supposed to just get the rows. I shouldn't change it. So I'm going to put a const at the end. And then I'm going to get the columns. And then I'm not supposed to change them too, because accessing means that you're just accessing. That's what you said, right? You just want to access. So you only going to have access privileges. So it's a read only. So basically what this means, it means that it's a read only. If you have that const there, it can only be read. Then we're going to have the get pixel, which takes in a row on the column, and set pixel. And if you check the get pixel, right, after we call it, what do? We assign its value. That means it returns a value. And what type of value does it return? A UJ pixel. So we're going to do that. Let's create it, UJ pixel, which basically, what the accessor that I'm creating right now, it's basically an accessor that gets this pixel, one pixel in the two-dimensional array. So I'm going to call it get pixel as per requirement. You should take in an integer, two integers, and you should only read the information. So I'm going to put a const at the end. And then we're going to have to create mutators. Mutators or setters. And then this is what we call getters, because it gets information. Setters because it sets information. And then let's see. We need to set. So as you can see, I don't say it's equals to something. That means it should return a void. I can already tell by that. And then I must take in R, which is an integer, and C, which is an integer, and rec pixel, which is a UJ pixel. So I already know how to declare it. So it's going to be void set pixel, takes in an integer and an integer and a UJ pixel, like this. And so far they didn't talk about whether it's by reference or they didn't specify all of those things. I'm just gonna take it by reference. You don't necessarily have to, because the record structure is very small. When we get to alignment padding, you're gonna realize this thing is very small. We don't have to worry about that, but I'm just following good practices, just taking it by reference. The class must have using the default constructor, rows, columns, stochasticity, seed values, blah, blah, blah. And then since we are making use of a default constructor, we're going to be using default values. So therefore I must create default values to use, right? Default and another thing that you need to pay attention to. They said default constructor, right? To read the rows, columns, stochasticity, and the seed values. So that means I shouldn't have any default rows and columns. I am getting them in a file. Because they said you should use a default constructor. If they had said you should get the rows and columns from that what, and then they didn't say provide you any extra details, then you wouldn't have to worry about whether to create constants for it or not. But for the pixel, it's gonna remember this. They said by default it should have zeros. So I'm gonna create a constant. So I'm gonna start with the keyword const, and then followed by the type. But the type of constant we're creating, right? Remember, I'm creating a constant represent the default pixel, right? Default pixel. So in order for me to do that, if you look at DJ Pixel's type, it takes in 4 integers. So it's an expression. So I should use const express. It's not a single value. It's a whole expression. So I must use const expression. Even double is an expression, because if you check double, you say 3 dot something. As you can see, there's that dot, there's that character there. So it's a whole expression. So for now, I'm just making a UJ pixel. So UJ pixel default pixel is equals to, and then I'm going to use the initializer brackets to initialize the individual values. So how many integers do I have? I have 1, 2, 3, 4. So remember that every integer is a 0 by default. So I'm going to say 0 for the red. I'm initializing the red here. Then I initialize the green value. Then I initialize the blue value. And then now I need to initialize the array. This 1D array, one-dimensional fixed array. So it's also something complex. There's more than one value in it. So I must use another pair of initializer brackets and then initialize every single element based on the number of elements in the array. There's 5 elements, so I'm gonna have five zeros. So I'm gonna have 0. It's gonna have 1, 2, 3, 4, 5. There we go. Everything is initialized properly. But then if I leave it like this, it just as const expression, UJ pixel, blah, 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 it's going to be a problem, because now what's going to happen is that every time we create a variable of this type, and we call that an instance of the class, yeah. So when you create an object or a variable of type UJ image, what's going to happen is that each variable or each object is going to have its own copy of this, which is unnecessary, because why? It's a constant. It never changes. So what's the point of each person having their own thing? It's like we are friends of 4, and then we buy the exact same with the exact same piggy bank or backpack. Instead of us wasting money to buy the exact same thing and for the exact same price, we can just buy one and share. So that's where static comes in place. You say static. Static means that we are sharing. We are all using that one thing. So we're going to use that one constant because it's the same. So I'm not going to have default rows and columns because, as you can see, they said in the default constructor, you get the values from the file. So I am actually reading the value. So there's never a case of I'm going to have default rows. So just keep that in mind. So there's stochasticity. Okay, so we also need to store this value. We also have what? Stochasticity. So I can create it as a private member variable here because I'm also storing the stochasticity as a part of UJ. I can do that, or I can just create it as a local variable in that constructor. So we'll see when we get to that. So let's see. Seed values for all the pixels. So the color components, red, green, and blue of the pixels must be initialized to 0. So yeah, that's pretty much it. Then now there's also information that I need to check here. So we are done so far with this. So for the stochasticity, I think I'm going to store it. Let me see. Is it necessary? Yeah, I think at some point it's going to be necessary. So let's just store it. Why am I storing it? Because the seed value is already stored. The rows and columns are already declared as variables. This is the only one that's not declared. So let's check what its data type is going to be, the stochasticity. The thing is, you can never be too sure or can never know what this type is until you really read the document. On the first line, they tell you that it contains rows and columns, and the stochastic value, which is basically the stochasticity, indicating the rows and columns of the image. So this indicates the rows, this indicates the columns, and then this indicates the stochastic value or the stochasticity. And a Y or N that you see, it's in single quotes. That means it's of type char. So it's a character. So the stochasticity is going to be a character. So I'm going to say char stochasticity. Then store it there. And then, okay, let me format my code a bit better, put spaces. There we go. That's a bit human friendly or human readable. Let's continue. So the UJ image has this class, has the what. So what I suggest you do, right, before you create the classes, you do all of these things. Before you do all of that, you need to continue and skip the inheritance part, all of this part where you have to inherit, blah, 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 and then go to T4 to add the remaining things that are needed in terms of functions and what into UJ image. So what is missing in UJ image? So in the UJ image class, you must add an overloaded assignment operator. So this question is always there, whether you like it or not. This one is always going to be there, this operator. The other two can change. The assignment operator needs to always be there because that's the basic thing that an object needs to do, or a type that you're defining. That's what it needs to do. For example, when you say int a, you can, that by default, you can say is equals to 19, right? You can assign it a value of that type. Int 19 is an integer, so I can assign it. I can use this equals operator or the assignment operator in proper terms. So I need to add that. So after the mutators, I'm going to have my operators. Operator over loading. All right, so what I'm going to do is I'm going to create assignment operator, right? So the way you create an operator, remember why we need to create this operator. Remember, we're defining our own type called UJ image. What class means, this class keyword, it means create a type, create a data type that has both variables and functions. That's what the class keyword means. With struct keyword, it means create a data type that has only variables. That's what it means. So at the end of the day, we are creating a data type. So if you remember the data types that we work with, they have operators. So you can add, you can subtract, you can say C out some integer value A with an end of, you can do that. You can use this operator. You can say plus plus A, you can say A plus plus, you can say minus minus A minus minus, you can say A minus 1, you can say A plus 1. You can use all of these operators. So the same thing applies with our UGA image or our class. We need to add this functionality for it to be able to work with some operators. You don't have to put all of them. You just need to solve the problem statement. So what are these operators that we need to put? So the first one is the assignment operator. So if you check the assignment, right, when you say int a, right, and then you say a is equals to 19, what's really going on here? So what's really going on is that you have the left-hand side, which is a, is equals to the right-hand side, which is 19. So the left-hand side is going to be a, the right-hand side is going to be 19. And then what's in between, we call that an operator. So this is the left operand. This is the right operand. Those are the terms for it. Operand, basically the values or the thing that's on the left and the thing that's on the right, or the thing that's after the operator or the thing that's before the operator. That's what we call the operand. And then the thing at the center of the two values or the two things, it's what we call an operator. That defines the operation that's going to occur. The operation that's occurring here is basically taking this value and storing it into this variable. That's the type of operation. And we're using the equals operator. So we need to also achieve this. So it needs to take in that value. And if you look at the value that we're taking in 19, can you change 19? While you're in the process of saying is equals to 9 to A, in the process of taking 19 and putting it into A, do you change 19 along the way? It's like when you during the process of printing, you you are inside the printer, you are scratching some things and saying, no, don't copy this, no copy this, no copy. You can't do that. You can't do that during the process. So we're gonna need to tell C++ that you can't change that value that you're assigning. And when you assign, what's the returned value of A? Or what's the type of value that I get back after assigning? I get back a 19 because 19 is now in the in the variable A. And what type is 19? It's of type int. In our case, we defined an image called UJ image. We defined a data type called UJ image. So I'm gonna get back a UJ image. And then I'm gonna use the keyword operator to define an operator. What type of operator do I want? It's called the assignment operator. I want the equal operator. And then do this. And then, so there's something that we need to fix here. So we need to, the value that's going to be returned. Remember, now we're working with objects. A class is going to be a variable of the type UJ image is going to be an object. So we need to get it by address. To make things faster, just get it by address. Don't get it by value. And then here, this is what you're going to take in, which is this value on the right-hand side, that 19. In our case, 19 was the same type as integer, so it was of type int. In our case, we want to assign a UJ image to another UJ image. So I'm going to take in a UJ image by reference again. And then this UJ image, this value that I'm taking in, it can be changed. So I put the prefix const there. It can be changed. And then That's it. Let me see. Okay, so we're not done. So another thing that you need to be aware of, the returned value shouldn't be changed. So remember, after storing this value into A, do you change it? Do you literally go to 19 and change it? I'm not talking about the variable. I'm not talking about saying A is equals to 20 or whatever. That's fine. You can assign A to a new value. What I'm saying is the returned value is 20 after it's being stored. Do you change it inside? Do you go and no, I want to modify that 20? No, you can't. So basically, I'm going to put a const there to say this returned value that I've assigned, it also cannot be changed. So that's where that const keywords come in place. Gonna be very important. So we've done the assignment operator. So now we need to support the stream insertion operator. So we need to be able to output the object. The same way we're able to say int A and say cout the value of A, we also need to do the same thing. How do we do that? We add it into the output stream. How do we add this object into the output stream? So there's a lot of things that we need to do. We need to include the IO stream. We need to include the IO stream, right? For this, remember what I stands for input. O stands for output. And this is a stream. There's two different types of streams. We have the O stream for output, and then we have the I stream for input. Here we are including both because we're gonna have to work with things like CR, C, yeah, so we're including both. And then these two things are stored in the standard namespace. If you don't believe me, you can just double check. I need to work with, remember I need to work with the OStream object, output stream. As you can see, it's defined inside the namespace called standard. So a namespace, the simple term to put it, it's like a packaging your data. You're saying, I'm gonna create a pencil. It's gonna have this name. This pencil case is named STD. That's the pencil case. And then I'm gonna put the tools that I'm gonna need inside of this pencil case. I'm gonna need a pencil. I'm gonna need a pen, an eraser, sharpener, all of those things. Those are the tools within the toolbox or the pencil case. So that's what this namespace is all about. So I need to specify which tools am I using and from which toolbox. So how do I do that? I say I'm going to use, so I don't want to use the whole toolbox, right? You don't want to use the whole pencil case, right? I don't want to use everything. I don't want to use the eraser, the rubber, and whatnot. I want to specify what I want to use. Let's say I only want to use one thing, a pencil. So I'm only going to use that pencil. So that's why when you open your pencil case, you only take the thing that you're using, right? So instead of me saying using namespace standard like this, I'm going to say using from the standard namespace, I'm using what inside of it? I'm using the OStream object. I'm going to make an OStream object or the OStream class. So let me see if it can show. Okay, there's the implementation where it's declared, whatnot. So you see it's still in the standard namespace. So this is perfectly fine. I'm using the right toolbox. The toolbox is, or the namespace is standard. And these two columns basically say take from that toolbox. And then you specify what you want to take. I want to take, or I want to use the OStream. And then now we can start creating that operator. So what's the operator? It's going to be, remember the operator, after outputting, what the operator will just return is the output stream. That's all it's going to return. So I'm going to say OStream by reference. I'm going to get it back by reference. Remember, references are always good. And then I'm going to say operator. And then this is the operator that I want to use. Then this operator is going to make use of two arguments. What are those arguments? It's going to be an ostream by reference. And this ostream is going to be like, remember, I wanted to work with with the output stream. I can use with that class, anything of this type, it needs to work with it. So basically it means that I can say C out and then I output, let's say obj image, right? So if you look at this argument, remember what I said, the operator always works with two things. We have the left operand on the thing before the operator and the right operand, which is the thing after the operator. Then we have the operator in between the two. So that's why I need to take in an ostream, because this is of type ostream. C out is of type ostream. If you don't believe me, we can check the IOStream. Check its data type. What's C out? It's a type of output stream object. It's an output stream object. So that's why I'm taking it like this. That's going to be my left-hand side, which is this one. And then my right-hand side is what? Image. Say UJ image, also by reference. But as I'm outputting this value, do I want it to change? I don't want to change. I just want it to output. That's all. So const. Done. Basically done with the creation of that operator. That's all you have to do. And then the last one is the pre-increment operator. So with the pre-increment, there's a lot of ways you can implement it. You can just make it a void like this, because at the end of the day, just a plus plus a like this, right? But it actually returns a value, right? So after adding this, it's gonna return a value, right? So remember what this plus plus means. It means add a 1 first. That's where the keyword pre comes in place. Add a 1 first, and then return the value after adding. That's what pre-increment means. So we need to do that. Adds a 1 to of each pixel, right? Of each pixel. So after adding, remember that after adding an integer here, if we double check this, let me show you an example. Let's say plus plus a. Int a is equals to 10. You should output 11 because it adds first, then it returns the answer. So if we check, I've built the project, build and run, build it again and run, the answer should be 11, as you can see. So that means it actually returns a value. I get back a value. And I get back the value that I'm getting back is the same type as the type of the variable itself. So I'm going to get back the UJ reference, UJ image like this by reference. That's what I'm going to get back. And I'm going to give it a name. The operator is, it's going to be the plus plus. And it takes in no arguments. It has no right-hand side. It only has the current object. And the return value, let me see. Okay, that's fine. I think if I put the const before like this, then the returned value, it shouldn't be changed. So yeah, we can do that, but let me see. No, if I put the const, it's gonna be a problem. Yeah, because what if they want to change the UJ image again? They should be able to change it. So yeah, that makes sense, because the same value 11, after returning it, I can change it again. I can C out plus plus a again. I can change the value again. I'm allowed to. So I shouldn't put that const there. because if I put the constant, it means that I'm stopping it from being able to change again, which is not what typically happens when you use a pre-increment operator. And then we are almost done declaring the class and how it should look. Let's do the alignment padding. So define UJ pixel structure as given table with alignment padding disabled. So let's put alignment padding. So the way I view alignment padding is in simple terms, it's basically a way to package the data. You give it a size. You give each item or each pixel a size. Let's say the size is 1 byte. And then each pixel, so that I know it's 1 byte, right? Remember, a byte is equivalent to 8 bits. And this keyword bits comes from bi meaning binary, TS coming from digits, right? So it's binary digits. What are those binary digits? Zeros and ones. So that means that whenever I package something in terms of a specific size, that means when the computer is reading the file, it knows when, it knows where does the thing start and where does the thing stop. So for example, I can have, these are four bits. It's 4 binary digits. Let me add 4 more. So this is now 8. It's 8 bits, right? So let's say we packaged everything in terms of 1 byte. So it's gonna see this first, it's gonna start here and starts counting. This is the first 0, the first byte, and then reaches the end, the last byte. Then it'll be like, oh, okay, so this is the end. This is the whole pixel. Then it sees another set of 8 bytes. It's like, oh, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I stop here. This represents 1 pixel. And then there's the next byte and so forth and so forth. So we want it to be able to do that, and this helps with the reading the file in terms making it faster to write to the file, to read to the file, because it knows when to start, when to stop, things like that. Especially when you work with things like binary files. So I'm gonna use this keyword hash pragma, and then I'm gonna pack my data and then push it in, and I'm pushing it, it's like literally pushing it, putting into, right? I'm putting it into, and then packing it in terms of 1 byte. So each UJ pixel will be represented by 1 byte. And then once I'm done, once I've reached the end of the byte. So after, remember it's gonna be like this. After I've reached the end, I must stop, right? I must make it stop. So I'm gonna just say pack and then pop, and then it's gonna stop there. Then it starts again, pack another set of 1 byte, and then it reaches the end, stop. Then pack another set of 1 byte, so forth. So yeah, we've packaged our data in terms of 1 byte each. So we have that. And then add a member function to the UJ image class, which will load the information from the provided text file. It will load information from the text file. So this is basically reading from a text file. This function must be called by the UJ image default constructor. So what this means, it means that it's not called in the main, which means it's not public. They said it should only be called inside the default constructor. So since it should be called only inside the default constructor, I'm gonna make it a private function or a helper method. Any function that's private is a helper method. It's basically a method or function that's meant to help make our code a bit short, to divide, to break up our code into sub problems. Because remember what a function is. It takes any code and then breaks it down into a sub-problem, and then each function solves a specific small problem, and then we add all these functions up to solve the bigger problem. So this, if you remember in maths, this is what we call first principles. This is the first principles, or you can Google it and search first principles thinking, which is breaking down a problem into smaller chunks and then summing up these chunks together to solve the big problem. So this function is just reading. So the return type is going to be void. It's going to return nothing. So it returns, and what's the name of the function? Load from text file. So it reads from a text file. And then now I'm going to use the string type, right? So I'm using the string type. So string is part of the standard namespace. So, and string is also part of its own library, right? So what I'm going to do is I'm going to include the string, right? Because I want to use the string. And since it's also part of the standard library, I'm just going to say comma, and I say from this pencil case, take another 2, which is the string. I also want to use the string. And then after building, this shouldn't have any errors. There we go. So there it is. It takes a file name. Remember, I'm not gonna call it file what that because I'm not coding here. I'm not necessarily coding. I'm not implementing anything here. I'm just defining how it's going to be structured. What are the things that define the object? So add another member function that will save all the pixels to a binary file of records, right? So it's gonna save everything to a binary file of records. And then if you read continuously, they say all of these functions you take the name of the file. I already knew, but you can just infer from what they've read or what they've written for you. So if you check the function here, it was actually called. It's called save to dat, and it doesn't return anything. It's a void. So let's do that, and it's public because you can see that it was called in our main.cpp. Functions for file handling. So these are the functions for file handling. So it's going to be void, give it a name. It also takes in a file name, which is going to be of type string. And then we are done with that class. I think not necessarily. Let's just double check if there isn't anything missing. Okay, yeah, we'll do the. So now we've written everything that was only related to. Okay, we're not done. The UJ class has a renderer which implements the draw function, which is a non-value returning member function that will set the pixel attributes of the UJ image. So I'm going to highlight these keywords. You should be very attentive to what you're reading. The UJ image delegates its own draw method. So we should also implement the draw method inside thingy, inside UJ image. And remember, this draw function is going to change the UJ image. So unlike the and remember, it's just a void. If you're not sure, you can double check inside the main. You see, draw. It's a void function. So void draw like this. So remember, it's not like the toString function, the one where you put a const at the end. It's not the same as that one. Remember the toString function, we put the const at the end because it doesn't change the object. For draw function, this function is going to change UJ image, so I can't put the const at the end. I'm just going to leave it like this. that should be it. That should be the way we should declare the draw function. So let's leave it there, and then we're gonna continue from T2 and start to create those classes, the composition, inheritance, etc. So that's it. See you in part 2.